Now we're doing the first order resistor inductor circuits. So we find the initial values first. At the initial values, the inductor will have no charge in it, so it basically acts as a wire, and then this is the only voltage source. So the current at this resistor is going to be 5 volts over 3.2 kilo ohms, which is the resistance across the whole circuit, assuming ideal components. Then we get 1.56 milliamps, and then after a while we can short circuit the after a while of the inductor being charged from the voltage from the source, we can short circuit the 5-volt source, and then we'll get the equation for KVL. 0 equals IL times 1,000 ohms plus 0.1 millihenries times the derivative of the current across the inductor over time. We got that equation is derived from the function where the voltage across an inductor is equal to the inductance times the time derivative of the current across it. So then that's the voltage for that component, and then the other one is for the other resistor, it's times 2200 IL. So then we can simplify that down to 0 equals 3200 times IL ohms plus 0.1 milliharads DIL or DT. IL is going to be the source, so that's why we have that as the current across these with the short-circuited voltage source. And then we can simplify that down to 0 equals 3.2 times 10 to the 7th IL ohms over henries plus DIL dt. Then using differentials, we get R equals negative 3.2 times 10 to the negative 7. Then we use our differential equations and we find the initial value of 1.56 milliamps, which is 1.56 times 10 to the negative 3rd amps. And then set that into the differential equation for A, and put R into the equation, R times T for the differential equation, and we get this. So that is so with the short circuit voltage, that's the value of our current generated from our inductor from the circuit.